In this lesson, we will address inverses. As we look at our function, here's the function, f of x is equal to x plus 4. We graph it and we pull out these ordered pairs. To make an inverse of this function, you follow the rules for a reflection over the line y equals x, which says take your yx and interchange them to take your xy and interchange them to yx. This will make an inverse function, and we write an inverse function f to the negative 1 of x. So when you make the inverse of this data set, you will take each one of these xy's and you will interchange them to yx. The domain of the first set, this domain, was 1, 2, 3, 4. This range happens to be 1, 2, 3, 4, because the domain and the range will interchange. The range for your first data set was 5, 6, 7, 8, and the domain for your inverse is 5, 6, 7, 8. We will then work to find an inverse equation. And when you find your inverse equation, you take your original equation, you interchange the x and the y's, and you solve for the new y. And then replace it with f to the negative 1. Okay. When you graph the original function and the inverse, it is a reflection over the line y equals x. This diagram shows you that the domain of x swaps with the range of the inverse function. If two functions are inverses of each other, we should be able to do f of g of x and g of f of x, and when we do these compositions, they will both come out to be equal x. This is the identity function. The identity because the line y equals x is 1, 1, 2, 2, 3, 3, and that's where the reflection is, over the line y equals x. So we're going to take these two equations and do f of g of x and g of f of x. Now we know these are not commutative properties. However, if these are inverse functions, they will both come out equal to x. So we take the g of x, and don't panic over the fractions. They pretty much work out if they're true inverses. We substitute the g into the x of the f, and we get 2 times the cube root, and this is going to be cubed. The cubes cancel out. The 2's cancel out. The 1's cancel out, and we're equal to x. Now the other way, we're going to take the f of x, and we're going to substitute it into the g of x. Substitute this whole equation into this x. So you're going to get the cube root of 2x cubed minus 1 plus 1 over 2. The 1's cancel out, the 2's cancel out, and the cube root of x cubed is equal to x. When both of these are the same and they're both the identity, we know that the original functions f of x and g of x are inverses of each other. A function is said to have a true inverse if and only if it is a one-to-one function. A one-to-one function says it has to pass a vertical line test as well as a horizontal line test. The inverse must be a function. Therefore, when you look at this, no two elements of the domain will repeat, and no two elements of the range will repeat. So we're going to start with this graph, and we're going to take a look at this graph. We're going to graph it in your calculator, and we know that this is radical. We have a domain restriction greater than or equal to 0, so x is greater than or equal to 3/2. So this domain is 3/2 to infinity. The range is 0 to infinity. When we reflect this, we want a line, our y equals x line, this is what we're reflected over, and we want this to reflect over to here. You could go in your calculator and take each point in this function and interchange the y and the x and graph a function that will look like this. It's inverse. The most important point is this right here. This is 3/2 0. When we interchange it, it's at the 0 3/2. And we can see the reflection over the line y equals x. Now we're going to make an inverse out of this. So we set this equal to y. We interchange the x and the y. And we solve for y. To undo a square root, we square both sides. And solve for y. And use the inverse. Now, you notice that this is going to give you a parabola, so we're going to have to restrict its domain. Well, the good part about this is that when we take its inverse, the domain from the original one now becomes our range. So our range is going from 3/2 to infinity. Our range now becomes our domain. So we can restrict this function to go from 0 to infinity, which we did in your graph, from 0 to infinity. In finding the inverse function, we substitute the f of x for y, and we interchange the y and the x. And solve for the new y. You can cross multiply this, add 5, or subtract 5, subtract 5. Subtract 5 from both sides. And divide by -3. Replace that y with the inverse notation. You can then check on your graph. You can put the original function into your y1 and put this function into your y2, and in y3 you could put the line y equals x so that you can see your reflection over that line. In this step, it's just a matter of putting this in your calculator. We have a draw function in your calculator. We do second draw. And you're going to come down to number 8. Then you're going to tell it, it's going to come out and say draw inverse. Then you're going to tell it y1 by going to the vars key, scroll to the right to the y vars, hit 1 for function, then hit 1 for y1, and then hit enter. And this will take this and graph your original function and draw its inverse. When you find your inverse equation, you can put that into y2 and see if you draw right over that one. It's a good way to check.